Hello dear friends, today we're looking at motion. But before we go to motion, I want to have a quick recap of our last class. Last class we discussed force. We said a force is a push or a pull. And we said that a push takes things away from you, while a pull brings things closer to you. We looked at two types of force, contact force and non-contact force. And we said that contact force is that kind of force where you have to have direct contact with the object. For example, a push, a pull, and friction. Then we also looked at non-contact forces, the kind of force that you don't have to be in direct contact with the object for force to act on that object. And we said example of non-contact force is electrical force and magnetic force. We now said that force can change the shape, the size, and the motion of an object. So that brings us to motion today. Motion, simply defined, is a change in position of an object. A change in position of an object because of force. When you apply force to an object, it can change its position. Now, if my ball was here before, right? So this right now is the position of my ball. Then I apply force to it. Is it still on my palm? No. The position of my ball has changed. Right now it's actually on the floor. It's just that you cannot see it. So motion is a change in position of an object because of force. Now, very quickly, because this is not actually the aim of our lesson today. But remember, I always tell you, knowledge is never too much. So I'll talk about Isaac Newton's laws of motion very fast. Isaac Newton is a very, very important scientist in the history of science. He's a very important scientist. And he came up with 3 laws about motion. He said that, first of all, a body. Now, when I say a body, I mean a thing or an object. A body at rest will remain at rest unless an outside force acts on it. And a body in motion will also remain in motion unless an external force acts on it. External means from outside. So this is a body at rest. It's not moving. It's not in motion. This is rest. So this ball can remain here in another 20 hours unless an external force comes to act on it. So that is what Isaac Newton said. Then his second law, this is a bit high for you. It said that the force that is acting on an object is equal to the mass of that object multiplied by its acceleration. The mass, we already said mass is what you commonly call weight. And I told you that weight and mass are not the same. So mass multiplied by acceleration will give you the force that is acting on an object. Acceleration is the ability of an object to gain speed. The ability of an object to increase in speed. That is acceleration. Then the third law says for every action, there is an equal and opposite reaction. Okay? Types of motion. Alright, these are actually higher languages I'm using here. But in the next slide, you will see that I've broken it down for easier understanding. Okay? Now, random motion is one type of motion. Random motion is the way gases move in air or the way smoke moves in air. There's no direction. It's just going zigzag. Okay, it's going randomly. Can you see the way my hands are going? It's just going in a zigzag way. All right. Then we have translational motion. In translational motion, you have rectilinear motion. Rectilinear motion means that an object is moving in a straight line. Then we have curvilinear motion. Motion in a curve. When your daddy drives through that bend that is taking you to school, he drives through that bend. That is the curvilinear motion. Then circular motion. Circular motion, round and round and round is a what? Circle. So movement in a circular motion like this. That is circular motion. Then rotational motion. You know how objects rotate on their own axis, like the earth rotates on its axis. It's in one point, but it's rotating on its axis. That's rotational motion. Then you have the oscillatory motion that goes to and fro, like that pendulum clock, that clock that goes to and fro from its main position. That is oscillatory motion. So like I said, I have simpler words here that can help you remember. Up and down motion. Now, like a seesaw, the seesaw you love to play on in the playground, that goes up and down, that is up and down motion. Then the straight line motion. Can you remember another word that we just said? The straight line motion. Rectilinear motion. Then we talked about the round and round motion, the rotational motion, like a merry-go-round. For the straight line motion, like a train, the way the train moves on a straight line on its tracks. Then the zigzag motion, you remember the random motion. In this case, they're showing you the way a snake slithers. Now, a snake doesn't walk, a snake slithers. So when the snake is slithering like this, that's example of a random motion, the zigzag motion. Then the back and forth motion, like the pendulum I mentioned, oscillatory motion, back and forth motion. So these are different types of motion. Now, in discussing motion, remember I told you that acceleration is the ability for an object to gain speed. So you cannot talk about motion without talking about speed and about distance. A very quick example. When you are running in school, you're running on your tracks, you're running a race, and you are all lined up. And Mr. Newman says at the sound of his whistle, you go. You try to run very fast. That's your speed. Then the distance is how much you have covered as a result of your running fast. Okay? So speed is how fast an object moves. Then distance is the space between 2 points, or how far one point is from another. And I told you when we learnt about measurement that distance can be measured in kilometers, in miles, in meters, and others. Now, a simple formula for calculating speed, distance, and time. Now, distance is equal to speed multiplied by time. And when you change the variables, you find out that time is equal to distance divided by speed, and speed is distance divided by time. Okay, let's look at these examples very quickly. On my left, there's a little car there. Okay, so the question says, I traveled 240 kilometers. The trip took 3 hours. What is the speed? And we already learned that speed is distance divided by time. Now, in this case, the speed is unknown. We are looking for the speed. But the distance has been given as 240 kilometers. The distance is given. The time it took to cover that distance is 3 hours. So you're going to divide 240 by 3. When you do that, you find out that your answer will be 80 kilometers per hour. Then the other one, the truck traveled 480 miles and the trip took 8 hours. What is the speed? The speed of that truck is 480 miles, which is the distance covered, divided by 8 hours, which is the time it took to cover that distance. And when you're done with your division, your answer will be 60 miles per hour. Then you're going to try out these simple questions. Number 1, simply define motion. Remember, some of you have not submitted your homework from last week. Do you know I'm still waiting? Please don't keep me waiting for too long. Submit your homework this time and make sure you answer your questions clearly, alright, and neatly. Very important. This time around, I'll take note of those that have not submitted, and in the next class, I'll call your names. Bye, friends.